This one is not working. Metallic is. Yes, now at the moment we are running behind the time. Since this paper 477 still not ready, maybe we'll go to the Q&A session. So once during that, if it comes, we'll see. That's now we have only 15 minutes. So shall we go to the Q&A session? Because the idea is that we need to evaluate the audience engagement, ability to engage, response to questions confidently. So there is a evaluation criteria. So to facilitate that, I would like all the presenters to come forward, right? So I had noted several actually each one question for each, just for clarification. Please, do we have another mic? Maybe here. No need to just. We have listened to the presentation many times, so I don't know what to ask. That is my first question. But just to fill this idea, because very interesting presentations, I will go one by one. The first presentation, computational fluid dynamic investigation of wind interference effect on structural adequacy of tall chimney structures. Now, first I want to know whether at the studies basically go around the Norachole power plant, right?
Yes.
Yes, it looks like that. Then, how many chimneys are there?
There are actually 3 chimneys.
There are 3. So, now based on your study, now that location is very specific location, because now we have wind towers also around, right? So the wind is blown from one particular direction. So based on your study, what is your what did you find actually for that particular location? What are the specific findings?
Actually, sir, we did not compare the existing structural demand. We get the model and the wind flow from that area. So what I found was that interference effect actually, even though there were 3 chimneys in that particular arrangement, the normalized base moment varies, the maximum one was about 1.1 from the compared with the isolated condition. So even analyzing the isolated condition for a long wind, it is enough for the group chimney design also. That's what I got. And we have to further study about the crosswind effects.
Okay, all right. So regarding this next presentation, nonlinear damping behavior of concrete elements by Mr. Disanayaka. Now, it's very interesting that you said the inherent damping in the elastic structures and the nonlinear damping. Now, according to you, when the corrosions exceed some thresholds, the damping looks to be stabilized. So, but then how about this nonlinear damping, the material nonlinear behavior, is it taken into account this?
Anyway, the material nonlinear is always there. Now thing is that that is not significant compared to the nonlinearity created or generated by the presence of a crack or some sort of a damage with some sort of frictional interface. That is why I said that even in any structure, even without a damage, there will be a nonlinearity in damping behavior. But for simplicity in engineering practice, we assume it as a constant damping behavior. But that is more pronounced actually at the end of the vibration.
What do you mean? End of the vibration mean like?
Where the amplitude is very low, only we can see that effect of nonlinearity is more exaggerated. But where we have a larger amplitude, always it's tend to dominate by the viscous type of or constant type of damping.
Yes, it is very, very interesting study. So the third one. Maybe do you have anything to ask?
Yeah, I have one question from Dilip, the first presenter. Now, in your validation, I just noticed that in the leeward side, there were some deviations compared to the windward side in your validation. Do you have any clarification regarding that in your
The
validation?
park validation?
Yeah. In your model validation?
Yes.
So, you showed your validation curve.
Yeah.
So,
Yes, sir.
in your CFD validation.
Yes, sir. Could you please repeat the question?
So in your validation, you have the windward side and the leeward side. So when you compare the validation points in the leeward side and the windward side, the deviations were much higher in the leeward side. So any clarifications regarding that?
Could be because that we have gone for the steady state run simulation, so it cannot capture the eddies eddy formation, so in the windward side. So that might be the reason that there's a slight deviation in the leeward side, but altogether the variation is less than 10%, around 7.39.
Okay. Then from Gihan, so then about this the decomposition. So the particular the decomposition that you have used is the variational mode decomposition. So that is mainly because the direct use of FFT is not might not be feasible for this the damping estimation process. So why this particular variational mode decomposition might be feasible in your process? Is it like why the other types of decompositions are not, for example, the empirical mode decomposition and so on?
Actually, I have used this variational mode decomposition, actually not for this one, but this is a kind of some sort of a byproduct. Why I use variational mode decomposition with some sort of my optimization, because I want to study very closely spaced modes. In that case, variational mode decomposition is very well suitable, because I want to decompose the closely spaced frequency component from a signal measured. That is why I use that variational mode decomposition, but it is very easily we could use for this one, because there we could not observe that type of closely spaced modes here in this experiment. That is why I actually use that one.
Yeah, then I've got one question from Ayanti. So that is about this the return period that you have used for Ditwa and all, that is more than I think 500, but for your routing you have used 5 and 10 years for this flood routing. So is there any particular reason for that?
So Ditwa is it's around 75-year return period monsoon. So I also derived the 100-year return period as well. With the help of, I used Ditwa event because when validating it was bit of high peak than the observed one. The problem was it's high peak, but it is an underestimation in the volume as well. It's because of the errors in the terrain canopy and all those things. But I used Ditwa to validate it because it's a recent event and an extreme event. So we can get an idea how it affects the area.
Did you compare with the available inundation data during that?
For Ditwa event, we don't have a complete inundation area maps from the government. We couldn't get it. But for the 2016 one, we could get inundation map, and it's comparably in a similar range.
So that 2016 event is what is the return period for 2016?
I can't remember.
Oh, no, you said you could get a better comparison, right? From the model and the
inundation maps.
Inundation,
yeah.
Okay. And actually my area is different. What is the confluence zone?
It's Ruanwell.
No. What do you mean by that?
Confluence zone is where a tributary river get merged into the major river.
Ah, right. Okay. So now there I had the problem is that now I think Dr. Sahan also asked So maybe, yeah, that's fine. So we'll move to the presenter 280, the time history evaluation of induced serviceability response. Now here you presented about how do you validate or how do you formulate time history analysis of a building under wind load. So now you presented effect of damping on the response, and also now this time history evaluation, how do you think you can, now this building looks like symmetric. Now I just wanted to get your idea how if it is a different shape, how will that affect your overall process of analysis? Where it should be changed, like okay, what should you do?
Yeah, basically
Unsymmetric building.
Yeah.
Yes. What are the?
In an unsymmetric building, we should consider the torsional response also, and also one other thing is the wind load coefficient. For a symmetric building, it will be like almost constant, but when it is not symmetric, in that case we have to consider the wind load coefficients around at each of the places, and also when conducting the analysis we need to particularly consider the crosswind response and the torsional wind response. So here we
does
have
your the existing methodology that you develop,
Yeah.
is that facilitating this, or do you have to do some modifications?
Yeah, I have to do some modifications and improve it to to get into account the asymmetry of the structure.
Okay, right. Yes, then I have a question for this one. Now this 365 is very interesting study, so that you discuss about the precast pier jetty connection, right? So that now other than this load capacity, so yes, I know this is the first time that I have seen the study, but I know that these structures you tested for the ultimate loading, right? And the connection is mainly through grouts, right? Grouting.
Grouting plus the dowel that we embed.
Dowels.
Yeah.
Right. So grouting plus dowel. Now, so at the moment the study is based on the load capacity, right?
Sir, yeah.
So is there any possibility that this can be affected due to the long-term serviceability? Because I know this type of structures could be built in the sea, right?
Yes, sir. Yeah.
So can there be effects? These dowels, everything is grouted.
Yes, sir. The dowels are grouted. For the long-term serviceability, we'll have to incorporate.
But what type of things that you may think this particular connection need to be addressed when it comes to the durability performance?
So since now we have only done for the monotonic loading, so sometimes there are sea waves and so on. So sometimes the cyclic loading and all those loading and unloading parameters can give the grout. Even though the grout is stable for monotonic response, sometimes when constant load is applied, it might not hold the robustness of the connection. So we might have to do some modifications and see whether this connection is robust even though for a long time period of loadings and unloadings.
Yes, yeah. Yeah, so I am 14 marks, okay. The final one, the ultra high performance concrete. Now you presented your study. Now, did you this study is now at the moment based on finite element based analysis, right?
Yes, sir.
So what is the Now, if you wanted to use this reinforced concrete beams, yeah, then what is your current recommendation based on what was your recommendation?
So the retrofitting.
Yes.
Yeah, for our selected control beam, we recommended a 40 millimeter jacket thickness on for the two-sided jacketing configuration to shift the failure mode from the shear mode to flexion mode.
Yes, so that is where that you had marked the capacity, right?
Yes, sir.
So that is the capacity from the experiment or the model, right?
Yes.
So I want to know whether there is a, now you have analytically calculate the capacity, or is there any method to calculate the capacity? You have not shown that. That is the experimental capacity you showed, right? Is there a methods to calculate it? How have you developed? I just want to know, are there methods to calculate the theoretical load capacity?
For the flexion ones, actually we use the ETAB software. We can use the ETAB softwares as well using the section analysis part.
Section analysis based on section analysis.
Yes, basically section material.
But the interface properties.
For this case, we considered it as perfectly bonded, but we can improve it by implementing like separate surface elements, interface elements, and basic different surface preparation methods as well.
Okay.
That's like we can improve this.
Thank you.
That way.
Okay, so with that we will finish off the question session. Tarun, sorry for keep you waiting. So we will proceed with your presentation and we will continue with your question session. Thank you all for the question and answering session. You can start your presentation.
So, good morning, sir. So, sorry for the inconvenience that happened earlier. So, today we'll be seeing the urban growth and forest change in the Kandy-Mahavali corridor. So, it's a complete satellite image processing study done for the years between 2015 and 2025. So, why this corridor? Why satellites? So, forest and green cover along the Mahavali corridor underpin biodiversity, soil protection, rainfall balance, and flood resilience. So forest loss here isn't only environmental, it feeds downstream water and flood risk. So the core question is urban growth directly replacing forest? So why satellites? So field surveys cannot track the changes that has happened for a decade. So let's see the study area the study has been done. So the study area is about 303 square kilometers in the Kandy district, the Katugostota, Kundasale and Digana corridor along the Mahavali river basin. So the river corridor is filled with hilly terrains, forest patches, growing settlements. This is a true Sentinel-2 color picture on the left side. So let's see how the methodology is, the processing is done. So the data set has been taken from the Google Earth Engine, has 2 pictures per year, like 2 images per year. So one image is from January to March and the other one is between June to August. So for the earlier seasons, we have taken Landsat 8 images, and for the later period, we have taken Sentinel-2, each image containing 3 index bands as NDVI, NDBI, and MNDWI. So the processing pipeline includes converting no data into non-data, remove out-of-range index values, and applying a 3x3 median filter to suppress noise and isolated pixels. And since we have taken image from 2 satellites, we have used percentile normalization to equalize the values between the 2 sensor images. And then the NDWI water masking is done before land analysis. So next we'll see the classification method I have used. So I have taken a threshold based pixel classification method with the four index values with the threshold I have given. So MNDWI greater than 0, NDWI greater than or equal to 0.50, NDBI greater than 0 and less than 0.40, and the remaining values are taken as bare and other. So let's see the results. So the forest has stayed the dominant class across the decade, about 280 kilometer squares every year. So 280.39 in 2015, 276.60 kilometer square in 2020, and 280.69 kilometer square in 2025. Net change over 10 years is just plus 0.30 kilometer square. So I report it as a relative change indicator, not an absolute build-up change. So next we'll see the other changes, but the stable total total hides the real story here. The core finding shows us 1.26 kilometer squares of localized forest loss and 0.08 kilometer squares of forest loss that has been directly turned into build-up. So there is no large-scale deforestation happened. It's localized and concentrated, as this change map shows, clustering near the city and along the corridor, and critically the change isn't scattered, so it clusters around the river basin. So let me be clear about what this study does and doesn't claim. So validation is so far visually inspected against high resolution images. So for built-up, NDBI cannot fully separate build-up and bare soil, which is exactly why I treated it as a relative change indicator, not as an absolute build-up change. So the two sensor record is equalized by percentile normalization. So absolute totals are read with that in mind, and thresholding was chosen for transparency and reproducibility. So to conclude, open satellite processing mapped land cover change across the corridor for a full decade. Forest was broadly stable at around 280 square kilometers, but localized forest loss was 1.26 square kilometers, and modest build-up growth are real, but it is localized and concentrated in a particular area. The workflow is reproducible and open. So my takeaway is forest cover is stable at the corridor scale, but the change is real and spatial and concentrated. The signal is location, not the total area. Thank you.
Okay, thank you for presenting your work. Now this was based on satellite-based data. So can you please clarify the resolution of this data? Because once you use the satellite-based data, one of the main things that we should be careful is the temporal and spatial resolution. So would you please clarify a bit on the resolutions, especially the spatial resolution of the data?
So the Landsat 8's maximum resolution, which I could download from the Google Earth Engine, was 10 meters square. And for the Sentinel-2, it was 30 meters square. So I have used percentile normalization, which considers the Landsat's resolution equal to the Sentinel-2's resolution.
Okay, now this presentation, you can also show the slides now as you are there. Can you show me one of the slides? So what I wanted to know that now throughout this presentation, slide number 7, that is where you showed the satellite, this data. So this, now what type of it's not my area. So what type of processing you have done now? We can say the 15 to 20, 20 to 25, or 2015 to 2025 map is there. So once you got this, what are the indicators that you have used to compare this?
So I have used 3 index values, that is known as normalized different vegetation index, modified difference water index, and normalized different build-up index.
So this particular area is where, what is the target area?
Katugostota Digana Kundasale corridor with the Mahavali corridor, river base.
So this corridor is how many kilometers around, like?
Huh?
How many kilometers? Like?
So the total area is around 303 kilometers square.
303 kilometers. Okay, thank you. Okay, thank you everyone. So this concludes the final presentation and the Q&A session of the session 3 engineering. So we had 7 presentations, and all the presentations were interesting, and it's good that we could have some Q&A sessions and discuss some of the ideas which are very interesting to the industry and the research. So with that, I think we can conclude the sessions. Now next, you may go for the tea, right? Thank you. Thank you, and also want to thank you, our session coordinators. Though I'm very sorry that I don't know the names. I could not write down, so I am sorry. Thank you for the support, and we'll conclude the session.
So thank you all our presenters for their insightful and thought-provoking researches. And as we conclude the technical session 3.4, I would like to take a moment to express our sincere gratitude. First and foremost, our heartfelt thanks goes to our session chair, Dr. Samit Buddhika, and also to our co-chair, Dr. Sahan Bandara, for their valuable support and guidance throughout the session. And also a special thank to all the presenters for your effort, dedication, and the contribution, your valuable research to the rich intellectual fabric of this conference. And also, of course, for all our participants and the audience members, your engagement and interest, and for the presence. And with that, we bring the technical session 3.4 to a close. Thank you all, and we wish you a pleasant day, and all you can go for tea. And we will be starting the next session in 15 minutes.
same computer I have.
Oh, yeah.
Elite, right?
Yeah, this is I'm a big fan of these. This is my second Elite book, actually. Looks okay. Looks okay? Okay. Oh. Can we test one more? Yep. That's good.
දෙපැත්තෙන් ඉඩක් කෙනා PP